Hello class, welcome once again to our session for today. So we will continue our discussion on the solvable groups of trigonometric trigonometric integrals. So last time we discussed group 1 integrals of the form, okay? The conditions m and or n are positive integers. And we have case 1, then we have example. We solve this example. So today we are going to continue with case 2. So case 2 is when n is odd. So for example, you're given this. When n is odd, take note that n is the exponent of cosine. So when n is odd, factor out cosine your du and then change the remaining cosine into sine using the identity. Okay, so using this identity. Then simplify and integrate using appropriate formulas. So same as what we have done in our first example for case 1. So we will also do the same for this example. Okay, so in this example class, we're given the integral of, so by the way, this is case 2. So case 2, our example is integral of sine squared x times cosine cube x dx. So case 2 says that, so take note in this class, for case 2, so when n is odd, so we have to follow this procedure. We have to factor out cosine u du. And then next, we need to change the remaining cosine, no? Change cosine into sine. Change cosine into sine. Then third, we have to use the identity. Use the identity cosine squared u equal to 1 minus sine squared u. And then after that, you simplify and integrate. So simplify and integrate using appropriate formulas. Alright, so these are the procedures that we are going to use. No, that is for case 2 where n is odd. So in our given, our n here is equal to 3. N is the exponent of cosine. So that is odd. Okay? So to continue, since we are going to factor out cosine u du according to our rule or this procedure here, so we have to break this cosine cube x into 2 parts or 2 factors. Okay, so we can rewrite this as integral of sine squared x, and we have cosine squared x times cosine x dx. So we break cosine cube x into cosine squared x times cosine x. Okay? Then after that, we use the identity. Now we have to change cosine into sine by using this identity. Cosine squared u equal to 1 minus sine squared u. Okay? So this is equal to the integral of sine squared x. So now we are going to change the cosine into sine by using this identity. No? Cosine squared, we have cosine squared u, so 1 minus sine squared u. So this is 1 minus sine squared x, and multiplied by cosine x. So multiplied by cosine x dx. Okay? So distributing, we have to distribute this integral sign together with the sine squared x as well as cosine x dx into each of this term. We have 1 as one term, sine squared x as another term. Okay, so multiply this with the first term together with this one. Then after that, multiply this also together with this. So this is now equal to integral of, so this will be sine squared x times cosine x dx, then minus, because this is minus, so this is minus, then distribute this integral sign, so integral of, so we have sine squared x multiplied by sine squared x, so that will be sine to the fourth x, then multiplied by cosine x dx. Okay? So using, as you can see here, because if you consider sine x as your u, derivative of sine is cosine. So this will be in the form of u to the n du. So let n be equal to 2. So our n plus 1 here is equal to 3. Then here we have n equal to 4. So our n plus 1 is equal to 5. Then let u be equal to sine x. So for this term here. And the other part, we can also let u also equal to sine x. So from here, if you take the derivative of u with respect to x, so this will be derivative of sine is equal to cosine x. Then solving for du, so just cross multiply dx or multiply both sides by dx. So we have cosine x dx. Alright, so that is our du. And similarly, for the second term, so if we take the derivative of u with respect to x, so we have the same result, class, because they're just the same. So this is also cosine x, then solving for du, so this is equal to cosine x dx. And then substituting, so we have integral of, instead of writing sine x squared, so we write u, no, to replace sine x. So we have u, then squared, then we have here cosine x dx. So if this is our u, so this is our du. Okay, so we express this in terms of du, where this one, we have solved this already as equal to du. So therefore, this becomes integral of u squared du. Alright, then minus integral of, so same with this, we have our sine x equal to u, so replace that with u, then the exponent is also 4, then times again this part here, which is similar to the first term, this is also equal to du, right? So cosine x dx is equal to du. So therefore, substitute this with du. So our integral now is something like this. Then using the power rule, power formula, so we have integral of u to the n times du. This is equal to u to the n plus 1 divided by n plus 1 and plus c. Okay, so that is our power formula. Then using that formula, so we can have our first term here becomes u to the power 3, or u cubed divided by 3, then minus u to the 5th power divided by 5, then plus c. Okay? I will continue it here, class, this part. Okay, so rewriting, I will just rewrite this. So we have the result here, which is u cubed divided by 3 minus u to the 5th power divided by 5, then plus c. Then substituting, so our u, as you can see here, our u, no, for this part equal to okay, this is our u, and the second term, our u is the same. This, so substituting, so we have, instead of u, we use sine x to the power 3, then divided by 3, then minus sine x to the power 5, then divided by 5, then plus c. Or we can rewrite this as 1/3 sine cube x minus 1/5 sine to the 5th power of x, then plus c. So this is our final answer. Although this one is already okay, class. That one. Alright, so that is the solution of this example for group 1 in case 2. Thank you very much. See you again in our next video. Bye.